Uh, I'll turn this into an artifact of record for the viewers at home. We'll probably skip quickly through some of the exercises that I had planned in case a larger group attended, and we can customize this to the folks that are here right now. Yeah, we're going to talk today about legible authorization, aka nailing UX without sacrificing security. If you feel like scanning this, there is a copy of the slides and a fig jam that we might hop into to assemble resources, and I'll make sure that after this, anything that comes up from y'all's questions, I have a litany of links to relevant stuff, so I'll make sure that there's some kind of take-home reading here. The TLDR is that for a long time, it has been often said that usability and security are in tension with each other. But for just about as long, actually, there's been a good thread from the HCI community and onwards that, in fact, the opposite is true. The more usable that you make your systems, the more secure they can be. So these things work in tandem with each other. If you feel like it, you can just share a bit about yourself in the document there, and that'll possibly speed stuff up later. But are either of you a designer or more on the engineering side? Developer. Yeah. Okay, cool. So I myself am a designer, and sort of to give you my bona fides, I guess, I first connected to the internet in 1988 through a 1200 baud modem, and over the course of the preceding 30-something years, I've seen a lot of things. Presently, I lead design at a company called Fission, so we build local-first identity data and compute infrastructure. I'll talk briefly a bit about some of the work that we're doing right now and why it has led me down this rabbit hole of making authorization more legible. So we have a few things. Some of them you may have heard of. We're the authors behind a local first authorization protocol called UCAN. We work pretty extensively in the IPFS ecosystem. We brought encrypted data to IPFS through something called WinFS. We're now extending the capabilities of that to provide compute over data in something called the interplanetary virtual machine. And so, of course, when you're passing payloads of data around, you want to make sure that folks are authorized to do only the right things with that data. And this means that, whether it's to developers or the end users, there's a lot of moments of authorization that need to be made legible there. We're currently focused on trustless off-chain distributed compute. And we also have, for client-side devs, something called Odd, which is an SDK, JavaScript based for the web right now, but also coming to native mobile, that makes it easier to work with those low-level protocols without needing to wrestle with the details. I also am here as a representative of CASA, the Chain Agnostic Standards Alliance. So that's where the working group that I facilitate right now, the Secure Design Working Group, houses our discussion. You can find it under their GitHub repo. A lot of folks there from wallet clients, the Wallet Connect team, MetaMask, Brave, et cetera, working to attempt to align on standards, many of which have been implemented today. So if you ever are dealing with chain IDs, that came out of CASA as a thing called we call our improvement proposals CAPES, so that was CAPE 2. We'll touch on maybe a couple of other interesting CAPES in a bit, but the thing that initially bothered me about the state of the industry right now, which I'm sure is like a non-controversial opinion, is that wallet clients and dApps work the least for people who need them the most. They still rely on a very deep technical understanding. And while not precisely blind signing, you're often completely unaware of what the contents of a message are. You're just trusting, you're depositing trust in the person who initiated the signature, right? We can do better than that. But we often beat ourselves up and we say that Web3 is not yet as good as Web2. Like, password managers are fairly broken as well. I've had to help a family member with dementia manage their accounts, and like, good luck getting somebody with that cognitive capacity to benefit from the security that a credential management tool is meant to provide, right? It's just not integrated enough, right? So another one of my favorite examples of this is 1Password. If you have to go through the recovery flow, they've obviously done a lot of UX research on where people are depositing these things, and the first place they ask you to look is in the downloads folder of the computer that you may have lost, right? So the failure case is happening really, really like early on, and it's whether you think we're in Web 1, 2, 3, or 5, I don't think that we've got all of the component pieces in place. We're still not at the first major 1.0 milestone for what would be a complete and usable system. So you got to make people empowered with information. They can do the right thing with their data. And we're at the point where a lot of that is possible right now, but it is sure as hell not probable. We focus presently on removing a lot of bad friction, but I think we also need to consider that there are elements of good friction that we should preserve or maybe even expand upon. So today we're maybe going to dig into a little bit more on what those points of good friction are. So my first question to the crowd is, and this is probably an easy one, but the difference between authentication and authorization, because this is sometimes not widely understood. Does anyone want to give an answer? Yeah?
The first one is who you are, and the second one is what you're allowed to do.
Boom! Nailed it. Yeah. So especially on the, for anyone who's coming into the space from a non-technical background, I don't think that we sort of introduce this important distinction right off the bat, right? Auth-N, who you are, Auth-Z, what you can do. And often who you are, like we talk a lot about identity. I think it's very important for us to be precise and narrow about what we mean in this space. We're talking about functional identity. We're not talking about like emergent rich identity, like who you are as an individual. We're simply talking about like a provable identifier of who you are, right? And that can have a lot of different flavors. We can do anonymous ones. We can do pseudonymous ones, which everyone is now saying pseudo-anonymous. I think just to make that concept a bit more legible to folks. There's identifiable records, and then there's verified records, where I've actually provably attested to the fact that I am such a person. But back to Auth-Z, does anyone want to try to list the 3 categories of authorization that typically are used? I'll give you a hint. The first one is access control. Can anyone think of a second one?
Permissions.
It's a good term. And maybe I'll just skip to the slide. Rules-based access control and object capabilities, both of which could deal with some other terms, which often we refer to these things as permissions, and that tends to be more often than not the user-facing term. We also talk about these things as privileges, and we talk about these things as capabilities, right? And so, sort of the first authorization approach that happened in the history of computer science was access control. This was to govern timeshare of the mainframe at academic institutions, and you signed in with a password and every individual person was identified and granted access. That's obviously unsustainable when you hit large numbers of people, so then you introduce this layer of abstraction called roles, which allows you to reduce the number of security policies in your software. But there's this other lesser explored approach called object capabilities, which attempts to encode the authorization into a token itself that is shareable, subdelegatable, and works offline at the edge without needing to connect with like a central authority to determine who's allowed to do things. And it's our opinion at Fission, and I know a lot of other people in the space share this, that the capabilities are a fantastic path forward. And you can emulate, from a management point of view, the same sort of screens and workflows that you would be used to with roles-based access control. Anyone want to guess what the first moment of DApp authorization is in a typical flow today? Like, if you're going to go use a DApp, what's the first moment where you're authorizing it, some capability?
Connect wallet?
Yeah. And what are you authorizing there?
The address.
Correct. And then what do you do next?
Proof?
Correct. By signing a message, right? And so presently, that's a little bit of like a wonky flow, because especially if you're doing it on mobile, and you're doing it through Wallet Connect, and this is surely no fault of Wallet Connect at the moment, you have to hop over once, select your account, hop back, wait for that to be confirmed and for the RPC data to be fetched, and then you hop back again, and you get a sign-in with Ethereum prompt or an old school, like, bunch of hexadecimal stuff, and you sign that, and then you're back again. So these are some of the capes that we're working on right now, which I think are going to be really powerful if you're on the Dapp side. If you're on a wallet client side, please take a look at supporting these on your end. But Cape 25 and 27, which would allow for feature detection. So if there are specific networks you're going to need, specific RPC methods that you're going to need to use that would otherwise break your app, Cape 25 and Cape 27 let the Dapp express that to the wallet client so that both the wallet client and the Dapp can provide more useful next steps back to the end user to say, oh, you're going to need to use a different wallet, or perhaps you're on an outdated version that you need to make sure you've updated to the latest because this is making use of a specific new RPC and method that otherwise the Dapp can't function without. Cape 222 is really cool because if folks align around that, it'll turn those two steps into one. And I'm just a designer, so I won't explain how that works because I don't honestly know. But I urge you, if any of this sounds interesting to you, to go check out the discussions on that. From the design point of view, these are three of the sort of key cornerstone papers that I, for whatever reason, made up the term pyramid of secure design to describe. But they are where a lot of the principles that guide us at Secure Design Working Group emerge from. Specifically, like the user interaction design for secure systems is a phenomenal read. But all three of these, if you haven't read them, I encourage you to. Within those three papers, there are if you add up all the principles that are proposed, you're at around 20. That's too many for someone like me who's simple-minded to remember. So I attempted with our group to distill this down to 7 guiding principles, some of which are not just about legible authorization, but about other aspects of it. We'll winnow that down to 4 or 5 of these for the discussion today. They are as follows. I'll quickly go through them. One, super non-controversial. Things should be easy and obvious. We know that human in the loop is like where things often fall down. And if things are complicated, then people are going to find a way to make the system easier for them, right? This is often what results in people writing passwords on sticky notes. So like, the stricter you make things, if you don't make them also easy to adhere to, you're going to really weaken your system, right? I'm not sure if it 100% belongs in this category, but I see a lot of dApps presently still don't honor EAP 1271, and in our push to move to a smart account-based world, this is absolutely critical. Session keys are a knife that cuts both ways, but obviously delegation of authority to the browser to do things without needing to hop back and forth constantly is very compelling. We're going to have to be careful about to what degree and how we let people sub-delegate. And then persistence data across devices and sessions is something we still don't really handle very well. Safe does some of this. I was really interested to learn the other day, actually, that there's a tab, I didn't know about it, that will persist the off-chain messages that you have signed across all of your sessions. This still obviously needs to route through sort of a centralized system, but keeping access to that stuff is going to be really important for us moving forward, so that we can provide better risk management opportunities to the end users. Number two, stuff needs to be maximally de-risked before it is launched, right? We also non-controversial, we do audits on stuff, but there's a lot more that we can be taking care of before it ever gets to the responsibility of the user themselves. Here, there's a lot of flagging of suspicious transactions through registries or evaluation of the payload itself or domain binding. You also have transaction guards and spend limits that you can apply to things like safe. We do simulation, a whole bunch of things there. But when it comes to the person themselves, and this really ties back to the session key question, we need to find the right granularity of expressing the request for permissions, right? This part is tough because you don't want to overwhelm people and nag them constantly and lead them to become habituated to just say, okay, 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 but you don't also want to overwhelm them with so much detail up front that they either panic and back out or say yes to more things than they should have or needed to in that particular moment. A bit later, we'll look at some precedents from the Android ecosystem, early research there that deals with that. For this step, interesting things for you to look at: UCANs, Cacaos, recap from Spruce ID, which is the authorization extension to their sign-in with Ethereum project. And then Dan Finley from MetaMask has put together an on-chain set of Solidity contracts to achieve, a set of Solidity contracts to achieve on-chain object capabilities that is called Delegatable. And that's still a very early project, but I know he's putting a lot of effort into it and finding ways to fund a larger team. So definitely some interesting stuff there. Things, of course, need to be sufficiently legible. I shouldn't need to be technical. Here, we got great progress with Seaway. There's some groups looking at human-readable messages at the moment, and there's a bunch of different strategies there. Things should be sufficiently auditable. This is somewhat solved, but not human-friendly for anything that happens on-chain. Of course, I can go and I can look back. I can go to revoke.cache. As I was mentioning earlier, Safe's messages tab is an interesting approach to knowing what off-chain messages I've signed and perhaps providing the clients or other services opportunities to flag things that I may want to reconsider or revoke or overwrite. And then we also need to be aware that things change, right? This is the common complaint about EOAs, obviously, is that if you do something wrong in the beginning, the only safe thing to do is abandon that account and at great cost and effort, move things to a new one. Here, obviously, there's a lot of great work on the smart accounts front. There's some interesting proposals, E5003 and 7377, which each describe different hard fork required approaches to migrating control of an account to a contract while retaining your public key address. And last but not least, if you've handled all that stuff, you still actually need to let the person do what they want to do, right? You need to thread the needle and ensure that whatever they were intending to achieve is still possible, as long as it's a thing that they should seek to achieve, not sign a phishing message or something like that. So the first exercise that I was going to do was for all y'all to just share something about the authorization problems that you have. Did anyone come with a live problem?
Maybe.
Yeah. What's the problem, if you're willing to share?
We have a DApp, and many of our users are not Web3 native.
Right.
So all of this sign stuff, Insta, MetaMask, it's just too much. And I think if we want to address a larger audience, it will always be too much. So we just integrated Web3 auth, which creates an EOA that lives somewhere, and the private key is assembled in the browser. But I wasn't very satisfied with the structure Web3 auth using this by itself. So we augmented it by creating a key share. We asked the user to store on their computer.
Mm-hmm.
And that improved things a little, but still I consider it less secure, slightly less secure than a hot wallet.
Right. And yeah, okay, so just to repeat the question, or the problem. You got like a mass market DApp for whom asking them to install a wallet client like MetaMask is perhaps a bridge too far just to get started. And so provisioning non-exportable keys in the browser through Web3 auth, but extending that a bit further to get them to download and self-custody a key share. And I can't remember Web3 auth is like BLS. Is that how it's working? Like it's an MPC-based approach to stuff?
MPC-based approach, which I couldn't audit, so I didn't use it. I used the older version, which is called T-Key. It was developed by Taurus, and it uses Shamia's secret sharing scheme.
Right. Yeah. So, and this is where like it kind of gets back to that initial account recovery issue that 1Password kind of drops. It's probably wrong of me to accuse them of dropping the ball, but there's like this the moment that you have to ask somebody to take this data and do the right thing with it,
Yes.
like you've already lost,
Yes.
basically.
Yes.
And there, I think some of the most interesting possibility is the passkey standard. So for provisioning, maybe like sponsored contract accounts, smart accounts, there are experiments at least, they probably need to get some more eyeballs on them, where you root control of the contract account in a WebAuthn FIDO Alliance passkey. Are you familiar with the passkey standard?
Apparently I'm not.
No, it's super interesting. Go to passkey.energy which is another like sort of weird living documentation site that we have. It works perfectly for your needs in Chrome, on desktop and Android, as long as you go into the settings and turn on a feature flag. It could work broadly across all browsers, and it is on a standards track adoption at the moment. But this would allow both signing key material and derived encryption key material to come from passkey. What's cool about that is passkey is already being adopted as a passwordless credential for signing in to like huge, recognizable household brands. Like in the United States and Canada, there's a big company called Best Buy. They're integrating this stuff. I think that you can already use passkey to authenticate into Google's services. iOS has first-class support for it.
Still don't get what it is.
It's just a passwordless credential, right? So it's like, again, just a designer, so I'll lose the words, but it's public key infrastructure that is built into these operating systems at a first-class level that you could use to provision on-chain accounts. And then, if you did it that way, and everything works, and we all agree it's secure, theoretically, that person just ends up, like this will be the way that people authenticate into all services and websites within the coming couple of years.
So how does it work?
I urge you to check out the demo. Yeah, go to, I think we have links to some of the other demonstrations from passkey.energy. And there you'll be able to try creating your account through a passkey. And then that will be synchronized across, if you were like I myself am a 100% Apple person, because whatever, I'm a designer. And those passkeys will be synchronized across everywhere where I'm signed in via iCloud, right? So it's not, for a certain threat model, what you want to be doing
It's device connected.
it's non-exportable from your device. To a certain degree, that device may mean that it is syndicated across everywhere that you are connected in your sort of personal cloud of devices. If you're cross-ecosystem, you can do a device linking QR code-based flow. So I could still have my keys domiciled on my phone, and the authentication handshake can happen via a QR code so that I could sign in on a desktop or anywhere else where the standard is supported. And again, it's like the latest version of major OSs and browsers all now support passkey. We need a couple more things to happen so that we can use it as the root of entropy for encryption as well. But yeah, for like signing, it's good, and there's some people exploring how this would work in this space, right? And then, so then the only question is later on when I've got like more stuff and I should maybe be a bit more careful, and you tell me maybe your threat model is sophisticated enough where you don't want to have that key material encrypted in your iCloud. Sure, like now let's add a separate signing factor, like I'm aware enough, I've been doing things for a while, and as we progressively enhance people's security through 2FA, we'd do the same thing, I think, right? Does that make sense? I would suggest looking at it. I don't know if I've solved your question, but...
Can we do another problem?
Yeah, go for it. Yeah.
Hey, I'm Alon from Redefine. We just integrated with the Safe wallet, and we provide them pre-transaction analysis. like every safe users, before he signs a transaction, he can see, we simulate the transaction, we run it through our policy engine, and if there is a bad impact to the user, we give an alert and with explanations why this is a bad transaction to sign. And the dilemma is how much data should we provide to the user,
Right.
in order to give him explanations, but not overwhelming with a lot of information.
Yeah, so this is like actually, so I don't know if folks have noticed, but in MetaMask, for example, recently they have started to add warnings that you should, ensure that you are dealing with an entity you trust and all the rest. And they noticed a significant drop-off in transaction completion at those steps because and this is like, a tricky thing because like that, I'm assuming for a certain cohort of people, they never saw that message before, and then now it's being put in there, and so they think there might be something actually wrong with this. So I think that, yeah, there's like an art in how to relay this to somebody, because what you're attempting to do is outfit them with enough information to make that assessment on their own, and you don't necessarily know, right? So I guess maybe my follow-up question is, in that payload, is there anything, to what degree do you ever have certainty that it is for sure bad for them?
So what we do, we have a variety of severities, like low severity, medium, high, and critical.
Yeah.
So for the critical and the high, we are really sure, and we can also like explain in English what's wrong and why you should care.
Yeah.
But I have a feeling that as long as the message, some people are not like even understand like what does this message means. Like not everyone is like crypto experts, and even if you're trying to explain to the user, I'm not sure that the user is getting the value that we're trying to provide.
This is where a lot of slow and tedious UX research and iteration basically is like the only safe path. And then like right now, where is that showing up for somebody, right? Like it's a separate plugin. It's a
no, it's on the safe.
Oh
wallet.
yeah, sorry, you said yeah, in safe, right? So yeah, I think like we're in this super interesting moment where because of, for example, the modularity of Safe Core, there's an opportunity for greater experimentation there. There, already is a plugin ecosystem in that we have MetaMask snaps landing, in production sometime soon, and so there's opportunities to, rather than right now where, for example, I think Revoke.cache has a browser plugin that will run kind of in tandem with your wallet and attempt to inform you about things that are malicious or suspicious that you haven't explicitly allowed listed from a certain contract address. And like parceling stuff into low, medium, and high severity is a great place to start. Then really just experimenting with the semiotics, like burying the details but making them available. And the whole lot of us working together to try and assemble a standard set of terminology to use industry-wide. Internally, a standard set of terminology to use industry-wide user-facing. Ideally that survives translation to other languages with reasonable integrity, and then also like has like example code backed UI patterns that we can all test and improve together. I don't know if anybody was around designing in or implementing in the early mid-2000s, but Yahoo UI library, back when Yahoo was like a relevant company, was an amazing resource that became a shelling point for that early phase of the industry, even pre-Ajax, pre-Web 2.0. And so, yeah, I think designing and researching out in the open as much as possible. I mean, this is kind of my pitch for the Secure Design Working Group, that hopefully more people ask those questions there. And then I don't know 100% of the work that's being done presently, but I know like 50%. And if more people keep showing up and adding to the GitHub discussions, hopefully this slowly accumulates a corpus of knowledge that like gives you an answer, or at least tells you what not to bother trying because we already did it and it failed.
Okay, thanks.
We're probably getting close to the end here. I think maybe I got 10 minutes left. Does anyone else have an authorization issue burning? Because if not, we can cycle back to these two issues and take a look at them through the lens of how to ask permission, which is this paper from 2013, I think, or 2012, done by some security researchers at Google who were working on the Android permission system back when it was very, very new, and looking at ways to escalate and manage and make decisions about requests for permission. So, 10 years later, this has been the bedrock of a lot of really interesting developments in both the Android and iOS ecosystem. And I think when we compare ourselves to Web 2 as a litmus test of whether we're hitting the mark, we should probably actually be comparing ourselves to mobile operating systems. And measuring by that standard, because they are really, really, really far more sophisticated, not yet perfect, but a better model to follow, I think. And here, if we walk through from left to right, the original notion of how you could use a decision tree to decide which permission request approach to use, you would start with, is the permission that is being, or is the action that is going to be taken with this permission revertible or severe? If it is both revertible and low severity, just automatically grant it, right? Side effects will be, controlled and recoverable. So no big deal. You don't need to ask the person for consent to use this data. Some implied consent happened from some earlier step in that case where they, hopefully they know what they're doing, putting the information on the computer itself. Past that, did the user initiate the request, or is this request rooted in some business logic, right? If the user initiated the request and the action can be altered, then we pop up what they call a trusted UI. Does anybody know this term? No. It's also a very vague term. I don't totally like it, but I could get used to using it. It basically means it's a UI that is unspoofable, that is originated from a system that inherently that user already has a trusted relationship with, right? So this is the photos picker on Android or iOS, right? Where you know that this is as an app, I can't make it look like this is the photos picker. One, because I don't yet have access to your photos. Two, because there's a lot of UI hints, shadows overlapping things and stuff being rendered outside of the canvas that the application itself has access to that subtly show to me that this is the real deal, right? And we don't have very many examples of trusted UI in the same way in the Web3 space, but for sure, the wallet client that you're using would be trusted UI, and dApps that you regularly interact with probably fit into that category as well, right? And then last but not least, does it need to work without immediate user approval? If the answer is yes there, that's where you would have used an install time warning, those manifests that you recall from the Android ecosystem where it's like this long laundry list of stuff that I will be providing just by downloading and installing the app, right? And it used to be the case that as an app, you could request pretty much everything that you would otherwise ask for with pop-ups right up front. And it was sort of like the onus was on the user to like read through that and decide whether it was worth it. So you had a lot of apps, obviously, like that just asked for everything. And the moment that you downloaded them, they had basically like root authority over all your data, and they would scrape it, right? They would upload all your contacts. They would start trying to siphon your photos. They would like just do all sorts of nasty things and sell that stuff. Over the years, of course, this is being clawed back, and now even you'll notice, like in the Apple ecosystem on Mac desktop, apps will ask for access to like read and write to various directories on your computer, right? In general, it's good to inform people about stuff that the app might be using at install time, but it's good to really restrict that list. And this is something that as we go further down the path of plugins, a la what's happening in the Safe ecosystem or MetaMask snaps, like we'll really need to be cautious about what is available at those moments. Otherwise, and this is going to be impossible to read, and I won't spend time going through it bit by bit. But there is this task we've been working on at Secure Design Working Group of attempting to update that how to ask permission decision tree and make it relevant to the Web3 ecosystem that we exist in today. So where does trust get rooted to make something become a trusted UI? What kind of questions can I ask to help me determine the degree of information that I should be disclosing to somebody up front versus hiding behind show me the extra information. Breaking permission requests down to isolatable things and asking for them at the most timely moment, right? There's been a bit of discussion in the industry over the last little while about how to like pre-request details in the DApp before you go over to the app, so that like the first expression of what is being requested doesn't just occur in the wallet client, that the DApp itself is able to prime the person for what's going to be asked. We do this all the time in mobile phone apps, right? Like you get to a point onboarding into the app where suddenly the app is going to need your location, and the best practice there is for the app to explain why. I'll show a quick example from a different slide. So this is the pop-up that you would then see, the equivalent being what shows up in the wallet client app. But before you would get to this step, this little purpose string here would have had like a dedicated moment in the app that goes, hey, I'm about to ask you for access to your photo gallery. We use this for X, Y, or Z. When I get then pushed over to this is an example of a trusted UI, do I want to limit access to the photos? Do I want to allow full access? In the Web3 space, there are going to be different options for how you as an individual are able to attenuate that permission without necessarily breaking the experience of the app. But like this kind of moment, I don't think is done often enough right now. And that pre-request message, a lot of folks are trying to treat it up front as an attempt to emulate the exact interface that will show up in the wallet client. And that's probably not the right path. The right path is to explain a little bit more about why this permission is being requested. If it's a spend allowance, like especially when you come into Web3 neophytes who like actually problematically may not know that this information is going to be default public on an immutable ledger, right? That they need to be informed about that. We don't actually do that anywhere in any of these flows because we know it's like, insiders spelunking and mucking around with things. So like, well, you're here, you downloaded MetaMask, I think you're already aware of what a blockchain is. As we move on to the next 10 million, 100 million people, they won't be aware of this. There's a narrative that has stuck in their heads about blockchains being anonymous, and so they think everything is private and untraceable. They do not know that these things are default public. So I think to avoid blowback when people do realize that, it's incumbent upon us to inform these folks about that part of it, to then inform them gradually as they onboard and need to take actions, what those are going to be, and then kind of work towards standards that will show up in the wallet clients themselves to make that like receiving part of that action in the trusted UI of the wallet client far more legible. We're done. We can take more questions, or we can talk outside while drinking delicious white wine or something like that.